Hi, I'm Dr. Samuel Allen Alexander, mathematician and philosopher, still here. Now, yesterday I worked for about 45 minutes on this Knight-Darwin law paper, only to then realize that the stream wasn't recording correctly. So that's annoying. Fortunately, I use Git, so we can see in the Git diff what all I did. Let's see, commit whatever is currently done. I'll call this commit work, which was not recorded due to technical difficulty. Okay, we already committed everything, so there's nothing on track. Now what I'll do is I'll do git log and look what stuff did I do yesterday? July 1st, just one commit yesterday. Okay, so we can just view that one commit. I'm gonna copy that commit hash and I'm gonna show that commit hash. So here's what I did yesterday. Added a paragraph, but then commented it out. A paragraph saying, in this paper, we use infinity as a mathematically formal and non-ambiguous replacement for vague predicates, e.g. speaking of infinitely long directed paths through a DAG, as opposed to the more vague notion of very long paths through said DAG, and so on. The drawback is that in all likelihood, according to our current understanding of physics, at some future time all life will have gone extinct due to the heat death of the universe. This idea of... I didn't finish that paragraph, and then I commented it out because I started to question whether that was really the right thing to put in the paper. And just because it's kind of distracting, I'm still on the fence about it. And then I put bullet points for the layout of the paper. I mean, the layout of the paper was already there, it just didn't have the bullet points. And then, where I had said, even if we had absolute certain knowledge that a certain species exhibited purely monoparental reproduction without a single biparental counterexample for the past 4 billion years, I added their text saying, well, I added a footnote saying, even for species typically held up as archetypal examples of monoparental only reproduction, such as bdelloid rotifers, the situation is still not completely clear. For example, a paper from 2020 reports evidence of genetic recombination in the bdelloid rotifer Adinata vaga. And somewhere in the paper I added this paragraph saying, it is intriguing to think about whether what we have called competition on triviality might have inherent biological meaning, aside from merely serving as a technical crutch needed to make a proof work. Competition does play a role in biology, and the non-triviality condition in question makes possible a kind of higher-level persistent competition. Not competition between individual organisms, but competition between lineages, for example, the monarchs of two countries or the leaders of two packs of wolves. In a competition-trivial set of organisms, such persistent lineage competition is prevented, for example, because of bottlenecks forcing the two lineages to occasionally overlap. And then, at the very end of the paper, I added a paragraph saying, in the future, we hope to explore variations of the IAP axiom and the Knight-Darwin law, which do not involve infinity, instead involving vague predicates like most members of the species, many members of the species. That should be pluralized. Let me fix that real quick. Many members of the species. Long directed paths, etc. These would obviously be more relevant for practical biology, given that according to our current understanding of physics, the biosphere will not endure forever. The drawback, of course, is that these predicates are vague, whereas infinity is precise and objective and mathematically formal. And then I started working on a figure for the easy version of the main result. And that's what I'm going to do now, after fixing that typo. I'm going to continue working on figures. I'll start from scratch. I didn't work very long on the figures yesterday, and wasn't very happy with what I came up with during that not very long time, so I'll just start over from scratch on the figure. I use Inkscape for doing figures. Now, I'm going to create a temporary document in Overleaf, and what I'm going to do in that temporary document is I'm just going to put some symbols that I need for the figure. The reason is I want to be able to copy and paste the necessary fonts into Inkscape, so I'm going to need, for example, I'll make these in an itemized list. I want U1, U2, U3, I want UJ, I want V1, I want V2, V3, I want an equals sign, I want V sub I want X sub 1, I want X sub 2, I want X sub 3, I want X sub, I believe it was it L? X sub n equals uj. No, x sub n. What was the L for? xk equals ul. I want u sub l, x sub k, x sub n. That's all I can think of at the moment. I'll probably think later of other things that I want, and I'm gonna download that PDF and I'm gonna open it in Inkscape. So that I can copy all these symbols. Ungroup this so I can copy the symbols. Copy those. Another benefit this has is it helps me choose the right scaling, because by default you kind of don't know how big things are when you're working in Inkscape. Okay, and the bullets also can conveniently serve as the vertices of the graph, although I think I'd prefer open circles rather. So I look at the bottom of the screen where it says the dimensions, and I want to make sure this is an actual circle, so I want the dimensions to be the same. So right now it's 7.32 by 7.32. Okay, and then I'm going to make the fill on this thing be empty, and I'm gonna make the stroke be solid. And then I'm gonna shrink this because this is obviously far too large. Shrink it down to about the size of those bullet points. Again, I'm looking at the bottom of the screen to make sure I'm scaling it the same amount in the X and Y coordinates. Now the stroke is a little too thin for my liking, so I'm going to go to the stroke style and bump that width up. Okay, there's a nice vertex. Maybe make it a little bit larger. Yeah, there's our vertex. Okay, now we're gonna have our U's. Let's draw an arrow, an edge. And we'll give this edge an arrowhead. That arrowhead doesn't look very nice to me. Let me try a different arrowhead. How about this one? Yeah, that one looks much better. Or that one. Yeah, that one's the best. Adjust it slightly. And now, once I've got one pair of vertices like this, what I'll do is I'll duplicate them and paste them so that the last vertex of one pair overlaps with the first vertex of the other, and that way you get this nice desired effect. I'm going to want U1, U2, ... So I'll have another edge and then the ... For my ... what I'll do is I'll take these 3 bullet points here and group them into a single object, scale it down significantly, but there's too much space between them. That's kind of annoying. Let's ungroup this. Take the middle dot and slide it up purely vertically, and then duplicate and overlap. Delete that guy. Still too much space. Let's make this even closer. Duplicate and overlap. Yeah, that's better. Now I'll move this over here. Go to Object, Transform, rotate this sucker by, let's say, this -20, good. Let's say -5 more. I think that's pretty good. Let's group them. I'm overlaying it on the arrow in order to see whether I got the angle right. I think the angle needs to be a little bit more. Let's rotate it by another 1 degree. Let's rotate it by another 0.25 degrees. Let's rotate it by another 1 degree. I think that's pretty good. Okay. Copy this guy, put him over here. That'll be our use of L. And then one more pair will get us to U sub, what, U sub I think, or something. U sub J, I guess. That'll be our U sub J. Let's put the labels on these. Here's U sub 1, U sub 2, let me put the U sub 1 on the left side because I'm gonna put the V's up above. U sub 3, U sub L, it occurs to me that I should get rid of those arrows and do more ellipses because we don't assume that U sub I comes right, that U sub J comes right after U sub L. So I'll put more ellipses there. That's our U sub L. Here's our U sub J. And another pair of ellipses after that. Which goes off toward infinity. There's our U's. Now we're gonna want a V1 and a V2. Move all these guys out of the way. I think I'll just copy the whole path. Delete the labels. There's our V1, V2, V3. And then there will be a VI. And we can just cut this path there. We don't need anything beyond the VI. And then the point is that the VI goes down to UL using X's. Let me revise this symbols list here. I want X sub n equals, I want U sub j equals X sub n, and I'm going to also want X sub k equals U sub L. That's temp symbols 1. On OS X, it's very difficult to resize the Inkscape window. Ungroup this, grab these symbols, paste them on in. Let's get rid of this uj here and replace that by uj equals xn. And get rid of the ul and replace it by xk equals ul. Why is the L not subscript? Because I forgot an underscore. Recompile, re-download, temp symbols 2, ungroup, grab that symbol, xk equals ul. Oh, and we also wanted x1 equals vi. Let's add yet another symbol. x1 equals vi. Download that. Temp symbols 3. Ungroup. Grab the x1 equals vi. Get rid of the existing vi and replace it with x1 equals vi. Okay, very good. Very happy with this right now. And then we'll have an x2 dot dot dot. X1 goes to X2. Which will then go all the way to XK. I want to rotate this thing quite a bit. That's pretty good. Yeah, perfect. A little bit misaligned here, so let's just select all this stuff and just move it. Okay, and let's put some labels, x2 and x3. Still a little unhappy with the misalignment here. Let me move this some more. Yeah, that's better. Okay. Delete all the unused symbols. And the point of the proof is that UL has two parents, UL minus 1 and XK minus 1. Which is clear from the figure. I kind of regret making these nodes so small. Let's make them a little bit bigger. Just growing my nodes here, just growing some vertices. There's probably a better way to do this, but I'm a mathematician, not a graphic designer. I think that's all of them. Yeah, that's a pretty respectable little figure there. Now we'll go to document properties and resize to content. And let's save this. Save this in writing, KDL. Fig1.svg, and we'll also save it as, well, let's see. Now I'm going to go look at my species logic paper and see how I typeset the figures there. Like so. Copy that, paste that. Here, I'll put in the tech file, see figure ref, figure 1. Label, figure 1. Include graphic, fig1.eps, caption, proof of proposition ref, preview prop, save the figure as an EPS file, by the way, which packages do we need in order to have these figures? Probably just GraphicX, right? Already using GraphicX. Okay. Upload the EPS file to Overleaf. And let's see if this compiles. It does compile. But I don't see the figure. Oh, am I looking in the wrong place? Proof. Oh, I didn't copy the tech file over. Copy the tech file over, recompile. There we go. We got our figure. Great. Oh. It's scaling by 5. Let's change that to scaling equals 1. I was wondering why that figure is so tiny. There we go. Figure 1, proof of proposition 7. Okay. Add fig1.eps to the Git project. and commit, add figure 1. Great. Now figure 2 will be for the proof of the main theorem. We might need multiple figures here. Let's look at the main theorem. The following theorem strengthens proposition 7 at the price of being more difficult to prove. Let S subset G and assume S satisfies the convexity axiom, S satisfies the IAP axiom, and S is not competition trivial. Then S locally satisfies the Knight-Darwin law. Proof. Suppose big U equals U1, U2, dot 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 is an infinite directed path in S. We must show some UI has multiple parents that big V equals V1, V2, dot dot dot, and big W equals W1, W2, dot dot dot, V2 infinite directed paths in S, as in definition 4, so Vi not equal to Wj for all ij. Case 1, all but finitely many vertices in big V are in big U. By discarding some initial segment from big V if necessary, we may assume all vertices in big V are in big U. By discarding some initial segment of big U if necessary, we may assume U1 equals V1. Subcase 1.1, there is some I such that UI not equal to Vi. We may take certain I as small as possible. Since all the vertices in big V are in big U, it follows that Vi equals Uj. For some j bigger than I. Now Vi equals Uj has two parents, Vi minus 1 and Uj minus 1, which are distinct since Vi minus 1 equals Ui minus 1 by minimality of I, and Ui minus 1 not equal to Uj minus 1 since j bigger than I. Yeah, let's do a separate figure for this subcase 1.1. We want Ui minus 1, Vi minus 1, Ui, Vi, and we want Uj. And Uj minus 1. We want the UV, the U's and the V's, we don't need the UL. Right, U1 equals V1, U2 equals V2, U3, we don't need U3. We want U sub I minus 1 equals V sub I minus 1. Then we want UI, and we want V sub I equals U sub J, and we'll also want U sub J minus 1. And I think that's everything we want. I think. I forgot a $sign here. Okay. Temp symbols 4. kind of annoying that Inkscape doesn't have a window manager. Now let's take this path here and copy it. And we'll delete the labels. U1 equals V1. U2 equals V2. UI minus 1 equals VI minus 1. And then we jump straight to UI and then the path continues. And eventually gets to VJ. To UJ equals VI. And the path continues from there. And the point is that, oh, wait, what? Yes. The point is that there's also an edge going from VI minus 1, from VI minus 1 to VI. I want to make this be smooth. How do you make the path smooth? That's not what I wanted. I'll just draw it from scratch. point tool. How do you do Bezier curves again? Yeah, like that. Want this guy to have the arrowhead. Yeah, good. Okay. Probably should consolidate figures. Let's save the changes for now. Save this as figure2.svg. Git add fig2.svg. Start work on figure 2. Now, I think instead of having figure 2, 3, 4, etc., we should have figure 2 left and right in order to conserve space. Subcase 1.1, I'll say C figure 2. Left. Left. Proof of subcase 1.1 theorem, main theorem. Okay, now what about subcase 1.2? Subcase 1.2 is that for all I ui equals vi, so u equals v preceded is in the proof of preview prop. No need for a new figure there. Now case 2. There are infinitely many vertices in v backslash u. Assume for sake of contradiction that no member of big U has multiple parents. For each I, let f of I bigger than 1 be minimal such that u sub f of I is a descendant of v sub I. Some such f of I exists because S satisfies the identical ancestor point axiom. V sub I has infinitely many descendants in S, and U1, 2, U3, dot, dot, dot is an infinite subset of S. For each I, since VI is an ancestor of U sub f of I, there is a finite directed path. It follows that each xij is in S. Now U1 has only finitely many ancestors, so there's some I0. So for all I bigger than I0, Vi is neither Ui nor an ancestor of Ui. Well, before I continue, let me upload figure2.eps to overleaf. And paste the new tech file. Okay. Now the question is, how many figures do we do for case 2? In principle, anywhere between 1 and 3, because you have one for the beginning of case 2, one for the base case, one for the inductive case. Now, let's do a figure for the base case. Since vi is not an ancestor of u1, f of I is bigger than 1. Observe u sub f of I has two parents, u sub f of I minus 1 and xi sub n of I minus 1. By assumption, no member of u has multiple parents. I want to think some more about how to do the figure for this case too. The figure or figures, plural. So I'm going to stop here for today. I'm Dr. Samuel Allen Alexander, mathematician and philosopher. Please like, comment, and subscribe. I'll see you in the next video.